Hello everybody, my name is David Willers. I'm a Senior Application Engineer at Shining 3D, and today I want to show you our OptimScan-5M Plus. This is our 3D scanner with a very high accuracy, so it has different field of use. If you want to change, we have different lenses and also different projectors. You just easily screw them out and screw the lens you need in. So you have the field of view 100, 200 and 400. I installed on this webinar the 400 already. Calibration is also done. And we will start with this bigger object over here. And I will show you how to scan with the markers on it. And we have another object over here. We will scan with just feature alignment. And for the last point I want to show you in the webinar is how to use the scanner with the turntable and the object on the top. So, first thing we need to do is a new project. So we can do just a single point cloud scan, so only one shot, or we can do a scan and registration, so multiple shots, or we can only scan the targets on a turntable, for example, and use them later as a reference. So, object 1. Okay. So, on the right side I see my camera windows. It's a live stream, and if the targets are green on both camera sides, then I can start to scan, and I click on measure. And you see that the OptimScan is doing the blue stripes, and here we see our first scan result. And it looks very nice. To get the whole object, we can move the scanner like that and take another measurement. Or we can also turn our object to a new position. More, 1 second. Like that. Alright, let's scan. So it's an easy and fast way to scan your object with a high accuracy. Only point is that. More of that. Alright. So the scan data from the OptimScan you can use for reverse engineering or also for inspection control. Later, after we scan it, we will show you how to inspect your scan. So now we have done all the scans. We can see it over here. One point I want to mention, you got also to the lenses different target sizes for the big field of view, middle and small. But as you can see also here, you can work with the big and smaller with one scanning field. That's not a problem. The scanner will see it. It is recommended if you have small areas where you want to put the markers, and use also the small markers which you got with the scanner. If we are done here, you can see on the left side all our scans. The first one is the fixed scan, and after that you have always a small deviation you can double check here. If you are saying, okay, I didn't need it, you can delete the last scan, or also if you switch it off in this tree over here, then for the calculation for the STL, the scans are ignored. So we will use now all our scans. So it's all started from scan, it's quite nice. And with the merge function, we can now create our STL. On the left side, you see what the scanner is doing. First, global registration from the 70 scans, and on the right side, you see the process, how far the software is. That takes a little moment now. So, what else can we show? We can prepare our next step. So I will put that away. And now we want to scan this object with feature alignment. So the software at the moment is deleting the overlapping area. Now it's merging all the files, 30%, so just a little bit. For scanning, also you can see, maybe I hope, and here are some data pointers. This shows you the focus of the scanner. So if you are going up with the scanner, you see that the lines are also moving. If you are like that, point on point, then you have the perfect focus for the scanner. You can also adjust it to the left and to the right, so that you have more angles and more views to capture the object with the scanner. So 40%. So with our next object, with the feature alignment, the good point is that you don't need to stick markers on the object. But have in mind that the accuracy is not as good as you would scan the object with markers. So now we're a few moments. So now we have finished our first scan example. Here we have now our complete STL, and we can save our STL or also the ASCII file if we want on the location where we need. Click on Save. So, for the next project, new project, project 2, say OK, and now we have to adjust our right. Okay. So with the exposure time, you can adjust the brightness of the scanner. So ensure that you see not so much red. And now you click on measure. I will turn the object. And click on measure again. And as you can see here, the alignment is automatically done by the software. But now you don't get any feedback of your quality of your scans if you do it with targets. So I can turn it one more time. And one last, and we have nearly scanned everything. So, and now we click on merge and get our STL file again. For the last object I want to show you, I prepared the turntable. There. So now I use the turntable. Put it like this. Checking if my scanner can see it in the cameras. With double click on the cameras, I get the big view of my cameras, so I can better see what the camera is seeing, and we need to go up. Like that. Alright. Double click again, and the window is small. So I will do a new project. Project 3. Okay. Good. So now we have on that side the turntable measure. We click on the function. And we are getting a new window control, turntable control over here. Here we can, the first step is to adjust the speed, so you can adjust the rotation speed of the turntable, fast, medium or slow. You can say if you want to register with targets on the turntable, or you can also calibrate the turntable with targets and then you can scan with it. You can auto scan mode. If you go up, you can set up the steps, as you can see here in the small ring. So for our case, I would say 30 steps. You can, if you want, auto registration after the scanning is done, so that you get finally the STL. And if you have, also now we have a dark turntable, so dark surface. If we would have a white surface or something, or a dark object on the dark surface, it can happen that we're capturing the turntable. If we don't want it, then we can use the auto delete points under the plane, and so we get a nice plane and everything under it will directly delete it. So now, just by clicking on start, the scanner makes its first scan, and as you can see, the turntable rotates. And here we overview, and now the software automatically scans your object, and you can do other things like checking your mails, having meetings with customers or something. So it's a very easy and automatic way to use our scanners with a very nice result. If you have So on the right side you can see on which position the turntable is. The green line says now we are nearly done with the half. So some more steps. The manual scan mode down here on the button is quite useful if you have done all the roughly steps you have set to your turntable and you see something is missing. With this function you can say that the turntable should go on 45 degrees and then you can make a scan of the missing area. So now the turntable goes back, all the scans are done. When it's finished now, I can show you, so 130 degrees, let's say run, and the turntable moves to 130 degrees, and we can add one scan over here manually. So, for the next point, we will show you how to inspect the big part. We scan at the beginning with Pointshape, and so let's do it now.
So, hi again. Now we are at our inspection software from the company Pointshape. This is the interface of the software, and on the very top you have some files, new project and open, some tools, also the view and everything that you can see here. On the next you have nearly the same with some more functions, and on the right side you can have the measurements function for distance, angle, radius, area, datum and GD and T measurements. For left side is the view and everything, and on the button you can switch off and on your results, which I can show you later. So to import some files is you can click on import cut first, click on the step and say open, say OK. This would be one way, or also one way is if you go to the location where you saved your file and you just drag and drop. Then the next question from the software is to set the unit. For us we can stay at millimeter. We have also, you can see here, some other units if you need. Say apply. So now both files are in the software. On the model tree, if we click there, we can switch off and on our scans or step files. And the first thing we can do is under polygons, we can decimate it, we can smooth, subdivide, merge, fill some holes, or a nice repair function. Then we click on detect. And on the right corner you will see that the function is working at the moment. One of two steps. And we click on preview. And we have 44 angle polyfaces, and we say apply. So 5 is left, so we can redo it until everything is solved, but just want to show you the function and say OK. So now let's switch on our step file again. So the first thing we need is an alignment. So on the top we have the alignment function, And also here we have a lot of different alignment. We can use what we need, what we expect from our measurement. So the nation alignment I will start now is that the software is looking to both objects and try to find a good alignment, as you can see here, for this object. So we say OK, and we can also say OK, now make the initial alignment. Now the arithmetical alignment is a kind of best fit alignment. We have here some more skews, and we say skewed. And here we also got a result from our AMS, so 0.05 millimeters, and then we can close it. And the next thing is I want to show is a whole 3D comparison. You just click on it, have some different types of methods, nearest or normal, sampling, maximally dust, and you can say apply. So now you can see the result. To see it a bit better, you can switch off also the something, and then you see the color mapping as a result. You can switch it off and on over here. If you say, oh, this is too much for the, I want to adjust, I want to not to, it's a millimeter, you click on options, and here you can say, okay, 1 millimeter, and here we take 0.1, say apply, and you see now how it changed with the different tolerances. So that was something. If you want to, for example, measure the distance, you can click over here and say point to point between two entities. That's other function you have for measuring the distance. Over here, I switch on my SCL thing again. I will switch off my comparison from that side to that side. This is my distance, and I can also do it with, for example, angel. I've been angel somewhere. Yes, we have 3 points, vector on plane, 2 planes, 1, 2, and here we have our angel angle. So, what else we can also do if we have made the, so we switch off the measurement over here and go back to the whole comparison. And if we are interested more in some of the areas who are blue and which are the real, we can choose some points. So we just start the function, click on the area we want to check. Here, here, here. Oh, so this one is also interesting. Over here, please select the points on the reference entires. Okay. So if there are no scan data, that's a bit difficult. And then we say apply, and then you can see here real more information about what is going on in this area. Okay, so also this we can switch off over here, and can also do sections like that, and we click here. Now, and now we can take the right one to move. See. Click check, and we can do it again from the side. Move a bit more. Okay. We say apply. And if we switch off now the whole comparison, our STL, we see here now our 2D comparison to our cut we choose. We can also, if we go back to object thing, can check some GNT over here. So we have straightness, we have flatness, synchronization, parallelism. So all the basic stuff we can do here. For example, click on flatness. I want to check the top area here, is it flat or not? Here's my tolerance. I can change to 0.8 or something. I select my target. Software is calculating. Second, PC is doing something. Here we go. And then we say apply. I think that was too much clicking from my side. No. Okay. So here you see the flatness on some areas. Or it's not so nice, but the actual value is 0.6 millimeters. We say okay. So, and we have now our measurements, we have our comparison, our points, our sections we have of 1G and D flatness. And so what is missing is now the report. So we click on report. And then we can add here very easily project name is object name project test. Date is author, DW, description, test, and here you can add your company logo. Open, and this is on that side. You also see that everything what I've filled in here is now filled into the report. Here you can choose what you really want to show in the report. Maybe the 2D measurements you don't need it. So our points are not so important for our reports sections. Something what you have in mind. You can also add some images if you want. And if you click on next, you see all the results which will be in the report. Click on generate. Then you can choose if you want the Excel file or just a PDF. And say report object 1, save. And if I go now, I have it here. I can open it and have my inspection done. Very quick, very easy, simple to use, and yeah. If you have more questions, then feel free to ask us in the FAQs later, or also have a look to Pointshape's website, and you will see more tutorials and information to their software. I just want to give you a rough idea what you can do, how to use it, how it looks like, how easy is it to use, and yeah, what you can do with this. So thanks for watching and listening. And yeah, as I said, if you have questions, let us know in the FAQs after that, and feel free to ask.